Hello everyone. In this video, I will talk about one of the transformation that can appear on your Cambridge Checkpoint Mathematics paper. It will be about enlargement. Look here. The diagram shows a triangle ABC on a grid. This one, the triangle ABC. Okay? And then A accent and B accent are the image of A and B after an enlargement. Look here, okay? A, plot the C accent as the image of C after the enlargement. Now, before you can plot the C accent or the image of C after the enlargement, you really need to know the scale of the enlargement and also the center of the enlargement. How to do that? You need to take a note here. Not like this, this thing, the panda. Don't sleep. Wake up, grab a notes and take a notes. If you have like an enlargement problem and you want to know the center of the enlargement, where the center of enlargements is, and then what will be the scale factor of that enlargement. The one that you need to do is, you need to make a line. You need to draw a line that connects the A of the shape and also the A accent as the image of the shape. So look here. The A and A accent. This one is the vertex of the triangle. This one is the vertex after the enlargement, the image, right? You connect it by drawing, or you connect them by drawing a straight line. So you need to use a ruler for this. And then the next one is, we also know like the B after the enlargement will go to here. So the same thing, you connect them by drawing a straight line. So it means you need to use a ruler. Can you find the intersection of the two lines that I just drew? Yes, here. This one, the cross there, is the center of the enlargement. So the center of enlargement, you can find it by intersecting two lines at least, that each of them actually connects the vertex of the shape and the vertex after the enlargement. So what will be the position of the center of the enlargement? It will be 1 above 1 on the x-axis, and then next to the 1 on the y-axis. So 1, 1. Okay? Now, after that, before I can draw the image of C, I also need to know the scale factor. Look here. From the center of the enlargement to the A, we have a gap of 2 boxes. After that, I enlarge it by 2 boxes again. So it means the original one, the distance between the center of the enlargement to the image is 2, and now after the enlargement it becomes 4. So 2 times what? So it becomes 4. 2, right? Okay, we check it again. The distance between the center of the enlargement to the B, it will be 2 boxes, 1 and 2. And now, after the enlargement, the distance between the center of the enlargement to the image of B is 4. 2 times what? So it becomes 4, 2. So the scale factor of this enlargement is 2. Now, we can draw this, the image of C. Look here. I will connect the center of the enlargement to the C. And then if you see here, when I connect these two, this line is actually the diagonal of 2 boxes available vertically. So if I want to enlarge this one with the scale factor of 2, then I need to have 2 of this, right? So this one will be 1. And then after that, I will have another diagonal of 2 boxes available vertically. So this one is 1 and this one will be 2. So the image of C will be here. This one is C. So I already answered the question, guys. Plot C, the image of C after the enlargement. I already write it there. This is the C accent, the image of C. Do I need to connect them to make it become a triangle? Well, for me, if you want to draw it as a triangle, it's fine. If it's not, it's also fine. Because why? Because the question didn't ask you to draw the triangle after the enlargement. Now we go to the B. Describe fully the enlargement from triangle ABC to triangle A accent, B accent, and C accent. Well, I can say that 2 points. So the first one, the scale factor is 2. And the center of enlargement is at 1 coordinate 1, 1. I hope you do get it. Bye-bye. Following the first video about the enlargement, now we will go to the other type of questions related to the transformation. And this one is for Cambridge Checkpoint Secondary Mathematics. The diagram shows shape A and shape B drawn on a grid. By looking on the question, I hope that you can directly notice that this one is a rotation. It's not a translation, reflection, and also is not an enlargement. Now, the question says that describe fully the single transformation that transforms shape A to shape B. And you get 3 points for this. Well, by writing rotation here, you will get 1. Now, after that, what is the other 2 points? Or what is the other 2 points for? Well, it means you need to give 2 more informations about the rotation. Well, for me, I will say the first one is about the center of the rotation. And then the second one is about the direction of the rotation. It can be either clockwise or anti-clockwise. And how far you rotate that shape in degree. We will start with the center of the rotation. Pay attention. The center of the rotation. First, shape A being transformed to shape B. So this one is the shape, this one is the image. Now, I will choose one vertex here on the shape. It will be this one. After the rotation, it becomes like this. Correct? Can you imagine that? After I rotate this one, based on a center of a rotation, based on the direction of the rotation, how far it's being rotated, then it becomes this, right? Then I will connect them. I will connect them like this. I hope that you can see the line. And then I will find the center of this line, the connecting line. It will be this. And then I will draw the line that passes this middle point, but the line should be perpendicular to the connecting line. So this one. So this one is the connecting line, and then this one is half of the line, and I will draw the line that passes this midpoint, but that line should be perpendicular to the connecting line like this. I hope that you can see that. Now after that, I need to draw one more like that. For example, I will draw for example, this one. This vertex, after being rotated, it become this, correct? This vertex, after being rotated, it become this. So I will draw it. I will connect them. I will draw a line that connect the vertex of the shape and the vertex of the image. I hope that you can see the line, like that one. And then I will find half of it. Look, if you look on the line, if you look the line carefully, actually this one consists of two diagonal lines of 3 boxes available horizontally, correct? This one is 1. 3 boxes horizontally, 3 boxes horizontally. So for sure, the midpoint will be here of that line. Then I will draw the perpendicular line, or I will draw a straight line that passes this point, but I need to be sure that that line is perpendicular to that. So that's why I use protractor. Look, this line, I will align it to 90 degrees, right? And then after that, I draw like this. This one is perpendicular. Now, the center of the rotation will be the intersection between two perpendicular lines of the connecting lines. You get it, yeah? Connecting lines is this one. Perpendicular lines of that connecting lines will be this. The connecting line, the second connecting line is this, and the perpendicular line will be this one. Now, the intersection of the perpendicular line, that one become the center of the rotation. It will be here. That one will be the center of the rotation. If you look here, the center of the rotation is above 1 on the x-axis and next to the 1 on the y-axis. So it means I can write it that the center of rotation is at coordinate 1, 1. 2 points. Rotation 1 point, center of rotation is at 1, 1 is also 1 point, so 2 points. The last one, how far that one is being rotated and what will be the direction. Well, look here. From the center of the rotation, I will draw a line to one of the vertex. Let's say this one. After the rotation, this vertex will go to here. Then I will also connect it to the center of the rotation. Now, look, from A to B. So the rotation will be from here to there. Can you see that? From there. I hope that you can see the arrow. From here to there. This one is anti-clockwise. So I can write anti-clockwise. For how far? You can use protractor. You can put the center of the protractor to the center of the rotation. Put the base of the protractor aligned to the line that connects to the vertex of the shape. And then you will see that actually the result of the rotation will touch the 90 degree. So anti-clockwise, 90 degree. You get the third point. Bye-bye.